Good day everyone. Welcome to the part 3 of this series about Microchip IoT Developer Guide for AWS. Before following the steps in this video, please make sure that you have watched the previous video tutorials of this series. In the previous video, we connected our PIC-IoT boards to AWS. We also observed the data coming from the board using the MQTT test client. In this video, we will demonstrate how devices can be configured to send and receive messages over custom MQTT topics. An example application will be implemented where button presses on any of the configured device will cause all devices to flash their LEDs. All communication will be sent between the IoT boards and AWS IoT core. No direct device-to-device communication will be used. For the first step, we would need to update our IoT core policy. We will include the button presses topic since we are going to use this to send and receive button presses message. Log into your AWS account. Click on Services, then click IoT Core. Under Security, click Policies. Next, open the ZT policy. Now, click the Edit Active Version button. The policy document will be shown. To edit this, click the JSON tab. Then, we will update the IoT Subscribe, IoT Publish, and IoT Receive permission to include the button presses topic. To do this, we need to add the following code as shown in the screen. Then, we will replace the placeholder with the AWS Resource Identifier. Then click Save as New Version. Scroll down and you will see the different versions of the policy. Make sure that the policy version that we edited is active. After updating the ZT policy, we will now modify a copy of the GitHub project. We will follow the steps in the repository. Click the link for the repository of your respective device. Then, download the project. After downloading the project, we will now modify the project file. The PIC-IoT and AVR-IoT have different procedures from this point. Click the link for your respective device. In this video, we will follow the procedure for the PIC-IoT boards. To edit the project, we will open the project using MPLABX. Next, we will need to edit the pin_manager.c. The purpose of this is to enable the switch 0 button of the PIC-IoT board connected in RA7. Add these following lines inside the pin underscore manager underscore initialize function. Next, add the following variable below the int underscore interrupt handler. This is used to store the interrupt handler for switch 0. Then, add the function below which sets the variable that we just created. Place it below the int underscore set interrupt handler function. Next, we are going to modify the underscore IOC interrupt service routine to also handle switch 0 button presses. In the pin underscore manager.h, we are going to add the switch 0 interrupt handler. Scroll all over to the end of the file and paste it below int underscore set interrupt handler. Next, open the application underscore manager.c and set the switch 0 interrupt handler before the system underscore initialize inside the application init function. Now, every time the switch 0 button is pressed, the send button press to cloud function will be called. Before implementing this, let's create a variable for the MQTT topic inside the application underscore manager.c. Add the variable below the MQTT subscribe topic. Next, we are going to add the send button press to cloud function inside the application underscore manager.c. Finally, build the project and upload it to your device. Now, we are going to check if the button presses are being sent to the AWS. Go to your IoT core, then click MQTT Test Client. Next, add button presses to your topic, then click Subscribe. When the switch 0 from the board is pressed, it will send that thing name. Now, we will modify the code again to receive MQTT messages from the cloud. Open your project again and go to mqtt underscore config.h located inside the headers, MCC generated files, config. We need to modify this line to allow 2 topic subscription. Next, we will add the following line for the board to subscribe to the button presses topic. The second parameter is a handler that dictates which function will run when a message is received to the specific topic. We therefore need to implement the receive button press from cloud function to handle any received messages. Then, add the following function definition to the application underscore manager.c to make the device LEDs blink twice when a message is received. Now, When the device receives a message from the topic button presses, it will run a test sequence on the LEDs. Build the program and upload the code to your PIC-IoT board. To test it, if the switch 0 button is pressed on any of the configured IoT kits, the LEDs on all configured IoT kits should blink twice. If this is not the case, make sure that the tutorial has been followed correctly and that the devices are properly conditioned. Here, I am pressing the first PIC-IoT. Then, I will press the second PIC-IoT.